Happy Tuesday, geometry students. I hope you enjoyed your day off yesterday. All right, as we get started, I would like you guys to go ahead and do a few things. First of all, if your cell phone is not in the cell hotel, please go ahead and do that. Also, please go ahead and log into Pear Deck. It is going to be a self-paced Pear Deck this morning, but I would like you guys to stay along with the video that you're watching at the front of the screen. So again, FBGZOS. Once you log into Pear Deck, you should see your warm-ups on the front screen. Go ahead and take about 2 minutes to complete those. Feel free to work with your partner sitting next to you, and in about a minute or two, I'll go ahead and give explanations for those. All right, let's go ahead and take a look at some of the solutions. Now, I know it's been a really long weekend, but a few things that I want to remind you guys from last week. First of all, there were two main points that we wanted to take out of Friday's lesson. First of all, anytime that we see a radius and a tangent, we know that they're going to be perpendicular. So we have that red right angle marking. Also, in this particular problem, we do have our isosceles triangle. So please do remember that anytime we have radii of a circle, those radius are going to have to go ahead and be congruent to each other. So O to our point of tangency has a tick mark, and O to the side of my circle has a tick mark. Because this base angle is 53 degrees, this one's also 53 degrees, I went ahead and used the fact that a triangle adds up to equal 180 degrees to find that 74-degree angle. Finally, I took a big look back from the picture and noticed that my central angle was 74 degrees. I have my right angle and X. Those make a larger triangle. And that's how I figured out that my value of X was about 16 degrees. For the second main concept that we should have taken out of Friday's class is that anytime we have two tangent segments that meet at a common external point, so they both meet right here for this blue one, we know that those have to be congruent to each other. So if this is 5, that will be 5. Same thing with the greens. They're both 25. And then for this particular problem, we ended up with two x's. Each of those x's are going to go ahead and be 8. All right, hopefully that helped with your warm-up there. We're going to skip right on into our lesson for today. So we talked about a lot of vocabulary from the other day. We have chords and we have arcs. And so we're going to go ahead and explore their relationship with each other. And then at the end of class today, we're going to do a few algebra problems. So up first, let's go ahead and quickly watch. This is a very, very quick video. We know
central angles and arcs theorem. This tells us that within a circle or within congruent circles, congruent central angles have congruent arcs. In other words, if angle AOB is congruent to angle COD, then arc AB is congruent to arc CD.
All right, so this would be extremely helpful on a problem like this. So why don't you guys give this a shot on your screens? Again, a reminder of that theorem. if the central angles, so the angles that hit the center of the circle, are congruent, then the arcs are congruent. And the converse of that is also true. So if the arcs are congruent, then those central angles are also going to be congruent. Work with your partner. Give this one a shot. Keep in mind as you're working that this is a straight angle. So this diameter of our circle is also a straight angle. So that can help us go ahead and find our value of x. All right, if all of your calculations were done correctly, we should have ended up with 59 degrees. So again, we saw those purple tick marks, and if those arcs are congruent, then the central angles also have to be congruent to each other. I know that 62 plus x have to add up to equal 180. We should have arrived at about 59 degrees there. All right, so here's the next theorem. So if the central angles are congruent, the arcs are congruent, and vice versa. This one says,
congruent central angles have congruent chords. So if we look at a figure here that says that if angle AOB is congruent to angle COD, then segment AB has to be congruent to segment CD. Again,
all right, and again, the converse of that is true. So here's your next one that I would like you to try with your partners. Now notice those tick marks on those two central angles here. I would like you to find the exact length, so no rounding please, of AB. Give this one a shot. Keep in mind those special right triangles that we have in there. So hopefully at this point, you're to the point of knowing that we have a 30, 60, 90 triangle in there. Now, a lot of people are finding the length of A to the right angle, but please remember we want to find the entire length of AB. And again, I encourage you to go ahead and work with your partners. All right, let's take a look at the solution here. So we know that if our central angles are congruent, then the chords have to be congruent. AKA, if the purples are congruent, then the green parts have to be congruent to each other. And the converse of this is also true, but in this case, we just have these congruent markings on the central angle. So I know that A to the right angle and B to the right angle have to be congruent to each other. Because this was 60 degrees and this was 90, our remaining angle had to be 30 degrees. Now keep in mind all of our formulas. We know that the 30 is across from the short leg. So we know the 4 is the short leg. The long leg would then have to be forward 3. Because we have forward 3 and forward 3, we end up with a total of 8 root 3. Now when we add these together, remember we add the coefficients. We do not add the radicals. Those are the like part of the like terms. All right, last video or last theorem also with all of these. So right now we know that if the central angles are congruent, then the arcs are congruent. And if the central angles are congruent, then the chords are congruent. Here's our very last one.
gods. And our final theorem for this video is the congruent chords and arcs theorem. It says within a circle or within congruent circles, congruent chords have congruent arcs. If segment AB is congruent to segment CD, then arc AB is congruent to arc CD. This is just a combination of the two theorems that we just learned.
All right. And again, the converse of this is also true. If the arcs are congruent, then the chords would also have to be congruent. All right, here's our last type of this problem. Okay. So again, with all of these, go ahead and take note of where you see the tick marks because those tick marks are going to help you figure out the rest of the problem. The only other hint that I would like to give you before you start working with your partner on this one is that please recall an entire circle is 360 degrees. All right, give this one a shot. All right. Notice our purple tick marks. So for this one, it says if the chords are congruent, hence the purple tick marks, then the arcs also have to be congruent to each other. So if this arc is 90 degrees, and remember your arc is cut by your chord, then this arc here would also have to be 90 degrees. An entire circle has a sum of 360 degrees, so our remaining value of x would be 100. All right, to put in summary what we just talked about, we know that if any of these are given, so these three lines are going to be interchangeable, but if I give you tick marks on the central angle, so angle DOC, so there's my red tick mark, and angle AOB, my other red tick mark, then I know some other items. Go ahead and take a good guess. Now, you guys remember, please use proper notation. So we're talking capital letters. Make sure that you either have your arcs or your segment bars above. Go ahead and give me what your other two conclusions would be. All right, my hope is that we made these two conclusions. So I know that if my central angles are congruent, so I have my red tick marks here, then I would know that my arcs are also going to be congruent to each other. Sorry about that. Okay, there we go. So I know that my arcs would also be congruent to each other. Okay. And I also know that my chords would be congruent to each other. So these are three interchangeable. If I ever see a tick mark on my chord, then I can assume my arcs are congruent. If I see tick marks on the angles, then I know the chords are congruent, etc., etc. So any combination thereof. All right. Last video for today, we're actually going to jump into a more algebraic part of today's lesson. So why don't you guys go ahead and get a look here. If you, for whatever reason, still don't have a calculator on your desk, you are going to need one for the second half of today's lesson. So please make sure you grab it as we're watching.
Second part of this video, we're going to look at a specific instance of two chords intersecting, where one of those chords is a diameter and they form a right angle between them. So it turns out that any chord perpendicular to a diameter or a radius will be bisected by that diameter or radius. In other words, these two segments have to be congruent. I'm going to take you through a few examples of how we can use this relationship and also prove to you why it's true, but before that, I just want to offer you a quick convincer. If you think about the symmetry of a circle, if I were to turn this circle so that the diameter is vertical, up and down, well, then if this line is perpendicular to the diameter, clearly this line is horizontal. But because of the symmetry of a circle, whatever's on the left-hand side of this diameter has to exactly be the mirror image of whatever's on the right-hand side of the diameter. So clearly, PB has to be the mirror image of AP. That could only be true if these two segments are congruent. That should be enough to at least convince you in your gut that this relationship should be true. Let's take a look at a few examples.
All right, so let's go ahead and take a look at a few examples here. So here's our very first example. And again, from what he just told you guys in your video, you know that this chord has a radius that's going at a right angle. So they're perpendicular to each other. Oop. And therefore, this chord should get cut in half. You guys know what to do from this point, right? So he's old, he's awesome. Give this one a shot. All right, so as many of you have discovered, for the remainder of these problems today, where we want to go ahead and solve for a variable, we are going to have to go ahead and use the Pythagorean theorem. So if a chord is perpendicular to a radius or diameter, then it is bisected. Many of us did not even have to use the Pythagorean theorem for this one. We might memorize the special triangle that it's a 3, 4, 5 triangle. But for the rest of today, we're going to be using a lot of the Pythagorean theorem. Now, let me show you guys one that's a little bit more complicated here. Okay. So I went ahead and I have this fun looking picture. I'm sitting here thinking to myself, oh my gosh, Miss Shannon, there's like not even a triangle here. So what I'm going to go ahead and do first is redraw my radius to make a triangle. So again, notice my radius and my chord are perpendicular to each other. It will get bisected. So I know I'm going to have 5 and 5, but here is my redraw. So if I take this radius and redraw it to form a right triangle, I now can go ahead and do my Pythagorean theorem. So this is really the right triangle that I'm looking at here, this 4.2, this 5, and then now what I'm going to go ahead and call my x. So I would have my a squared plus b squared equals c squared. Now keep in mind, this red line is your hypotenuse because your hypotenuse is always across from the right angle. Finish solving. When I take the square root, for this one it did ask me to round to the hundredths place, so we should get 6.53. So there's two main concepts that we need to make sure that we're keeping an eye open for. First of all, anytime that we have a radius, a diameter, whatever, perpendicular to a chord, it will bisect that chord. So instead of being 10, we're 5 and 5. The second part of today that's super important is that we need to sometimes redraw a radius to give us a triangle that we can use to solve. All right, why don't you go ahead and work with your partner and try this one. If you and your partner are stuck, take that 15, that radius of 15, and reposition it so that you have a triangle. Notice the directions. You do want to round your answer to the hundredths place. All right, so when I redrew, I ended up drawing my radius so that it went ahead and met with my chord on this circle. And again, you could have drawn yours also to go ahead and intersect over here. Once I do that, I now have a triangle, which means I can go ahead and do the Pythagorean theorem. Now notice how I reintroduced a different variable. So x is the length of this entire chord. When working with my triangle, it's only half of the chord. Therefore, I went ahead and called from the chord to the right angle, or from the point on the circle to the right angle, y. Then I can use my Pythagorean theorem. Once I got that answer, I know that only half of the chord, the part that makes my triangle, is 12.6. We're going to need to make sure that we multiply that by 2 to get the length of the entire chord. All right, we have 2 of these left. Let's go ahead and give this one a shot. This one's a little bit tougher, and again, I would strongly recommend that you and your partner put your brains together. Do keep in mind that this right here was a radius, the 15. We need that in order to be able to do our Pythagorean theorem. All right, let's give this one a shot. Again, really pick your partner's brains. We know that we want to find the radius of this circle. Okay, we're given that BC has a length of 5 and PQ has a length of 30. So let's start by labeling our circles with those given values. After you've labeled your circle, I would strongly recommend drawing in your radius to form a right triangle, because we are going to have to use Pythagorean theorem to solve this. The tough part about this particular problem is deciding what the length of the radius is. Now keep in mind, what you just drew in was a radius. So if you went from O to P or O to Q, either way, that would be the radius of the circle. But we already also have a radius pre-drawn in this problem. And keep in mind that the radii of circles are always the same length. So go ahead and take that information and see what you can do to solve this one. All right, another little hint before I go ahead and show the solution. So from the center of the circle to point B, so OB is a radius, and that is an X and a 5. So I know that my radius of the circle is always going to be X plus 5. That also holds true for either OQ or OP, depending on where you drew in your other radius. At that point in time, you should have a nice triangle to do Pythagorean theorem. Now, knowing your radius is x plus 5, be very, very careful when you go ahead and square x plus 5, right? Remember, that's x plus 5 times x plus 5. All right, I'm going to give you guys about 1 more minute to try to figure this one out. All right, let's go ahead and take a look at this problem. This one was really, really tough. So after labeling, we know PQ is our chord and it's perpendicular to our radius, so it's bisected. So we have 15 and 15. We're given that BC was 5. We need to go ahead and use some type of variable. So O to C was my variable. I know that if O to B is a radius, O to Q was also a radius, and therefore they have to be the same length. So if this is x and 5, this would also have to be x plus 5. Remember, x plus 5 times x plus 5, you have to distribute that out. Thankfully, both of our x squared subtract out of our equation. We get x to be equal to 20, but be very, very careful. X is the length from O to C. Keep in mind that it asks you to actually find the radius of the circle. So we would need to take our 20 and add 5 to it for a total of 25. Now keep in mind, you guys, these diagrams not always drawn to scale. Okay. All right, let's try one last of these problems. For this particular problem, I'm giving you 2 congruent circles. So circle A and circle B are the exact same length. If AB is 24 centimeters, okay, so keep that in mind, and they have a radius of 13, how long is the chord? So first, let's take AB. We know that A to the right angle and right angle to B would each be 12. think about where you could draw in your radius to create a triangle in order to do the Pythagorean theorem. So that's really our second goal of today, is to go ahead and be able to solve these algebra problems within circles where we have to make a right triangle and do our Pythagorean theorem. The difficult part about this particular problem is where to draw in that radius. So if we wanted to go ahead and form a triangle, you can do A to C. You could also have done A to D or B to C or B to D. It doesn't matter where you draw it, but it does matter that you start at the center and go to where those circles intersect. This would go ahead and give us a 5, 12, 13 triangle. So if you knew that Pythagorean triple, there was no need to do the work off to the side in red here. I know that if the length of x is 5 and I wanted the length of all of CD, I would need to multiply by 2 because, again, anytime that we have a radius or diameter that's perpendicular to a chord, it's bisected. So we get a total of 10. All right, we have one last little theorem that I would like to show you guys today. And it goes a little bit along the lines of this. All right, I'm going to go ahead and take a look at all of the values up here in the corner. Let me see if I can, there we go, make this a little bit better. So notice here that I can go ahead and change the lengths of the chords. But the really interesting part is that if I make the chords equal, I'm trying to get them both to 4.53. Oh, it's really close. There we go. Of course, it's not working, right? There we go. If I can get those chords to be the same length, notice they're the same distance from the center of the circle, which makes sense because if you were to take two sticks of the same length and try to put them into a circle so that their endpoints are on the circle, they would end up having to be the exact same distance from the center. So again, the more that I kind of move these along, if I make it bigger, so if I make this 5.09 and I make this 5.09, notice they're going to go ahead and be relatively the same distance from the center of the circle. So we measure distance perpendicularly. So moral of the story is this: if AB and CD are the same length, then OE and OF also have to be the same length. And again, the converse of this is also true. So how does this help us? Well, if I go ahead and have a picture like this, notice this chord is 3 away from the center. This chord is also 3 away from the center. So these chords should have the same length. Same thing here. If this chord has 2 tick marks and this chord has, these chords are the same length and therefore they should be the same distance from the center. I really like these particular problems because they're really quick, like really, really, really quick. So go ahead and tell me what my value of x's are for both of these. And if you said 16, because again, these chords have to be the exact same length. So if this is 8 and 8, we'd have a total of 16 because they're both 3 away from the center. So if they're the same distance from the center, they have to be congruent to each other. Now notice in part B, these both had the same amount of tick marks. So this had 2 tick marks and this had 2 tick marks. So if those chords are the same distance long, then they have to be the same distance from the center, and therefore it's 5. All right, you guys, that was a lot of information to digest today. Why don't we go ahead and jump in and start working on our Math Excel homework assignment for tonight, chords and arcs. Now, keep in mind a few things. First of all, please start bringing headphones starting tomorrow. Second of all, as you're working, pick your partner's brains. If you're stuck, go to the ARC, send me an email. You guys have a lot of resources. Also, please keep in mind to continue going ahead and working on any retakes or any missing homework assignments. All right, you guys, hope to see you tomorrow. Have a great one.